Hello everyone, welcome to the channel Top Gate. In this video, I will discuss race condition in process synchronization. So till the previous lecture, we have already seen that what is a process, and we have already studied about the various process scheduling algorithms or the CPU scheduling algorithms. So we have already studied about the FCFS algorithm. We have seen what is the SJF algorithm, the priority algorithm, the round robin algorithm. Now the main reason behind studying those process scheduling algorithms is that since we are having more than one process at a time and all these processes needs to be executed on the CPU, therefore there is a need of scheduling. Fine. So if there is only one process, there is no need of scheduling. But since we are having several processes in the system at the same time and we have to give time to all these processes, the process cannot wait there indefinitely. Therefore, there is a very strong need of scheduling these processes. So based upon the situation, based upon the requirement of the process, we use certain algorithms, and with the help of algorithms, we schedule these processes on the CPU. So that is the main reason why we studied about the process scheduling algorithms. Fine. So now comes to this process synchronization. Now we know that we have several processes to be executed on the CPU at the same time. Therefore, at certain times, at some situations, there is a very strong need that these processes must cooperate and coordinate with each other. They must learn to cooperate and coordinate with each other. These processes will only be able to cooperate and coordinate with each other if they are synchronized with each other. Fine. So now what is the need of process synchronization? That is why these processes needs to be synchronized. So I mean every process will not be synchronized. Only those processes will be synchronized with each other who are using the same data item. Fine. So I'll tell you with the help of example, I'll give you a very basic, real world example, and I'll try to explain to you what is the process synchronization, and then I'll give you a technical example also that will make you understand very clearly that what is a process synchronization and what is the race condition. So first of all, let's try to understand with the help of this simple definition that what is the race condition. So a race condition says a situation where several processes access and manipulate the same data concurrently is called the race condition. So notice there are few very important things, that is access and manipulate. That are the two very important things. That is, it is a situation where more than one process they are trying to access and manipulate. That is, we have an and in between. That is, there should be access also, there should be manipulation also. That is, some data item is there and this data item is being read as well as this data item is being updated also. So we are performing the writing operation in that data item also. So a situation where several processes access and manipulate the same data concurrently at the same time is called the race condition. That is, we have several processes and these processes are accessing and manipulating the same data item at the very same time. Then this situation is called as the race condition, where the processes are racing with each other to access and manipulate the same data item. Clear? So that is a simple definition. So now let's try to understand this with the help of a real world example. Suppose we have a tube light and this tube light has multiple switches. Fine. And these multiple switches are two-way switches. So, I mean, most of you will be having this kind of tube light in your homes also. This is it is the biggest example of the race condition. I'll tell you how. Suppose we have a tube light. So I'll just write it here. There is a tube light. Okay. And we have switch 1 and we have switch 2. Clear? So switch 1 and switch 2, both these switches can be used to operate the tube light. So currently the switch 1 is in the off mode and the switch 2 is also in the off mode, and of course the tube light will also be in the off mode. Clear? Because both the switches are in the off position and the status of the tube light is off. Clear? Now suppose I press on to this switch 1. So this switch 1 is now on. As soon as I press on this one, this tube light will go on only. Okay. So currently this switch 1 is in the on mode and switch 2 is, let it be, off mode only. So the status of the tube light will be on. Fine, that is the first situation. Second situation, suppose I'll just keep this switch 1 to on only, and this switch 2 I'll press it on. As soon as I press on this switch 2, this tube light will go to off mode. Clear? Now you see in this one that switch 1 and switch 2 both are in on position, but the status of tube light is in the off status, off mode. Why this happens? Because these two processes are not synchronized with each other. Clear? So that is called as the race condition, in which more than one process, they are trying to access and manipulate the same data item concurrently. Clear? So if we are trying to access and manipulate the same data item concurrently, then a situation like this can happen. So this condition is called as the race condition. Clear? So because of this race condition, these processes needs to be synchronized with each other. If they are synchronized, then a situation like this will not happen. Clear? So this is a general example, a real world example, and this is a very biggest example of the race condition. Now let's discuss a technical example of the race condition. So suppose we have an account in a bank, and this account has two joint account holders, person 1 and person 2, and they both have the ATM cards also. They both can withdraw money from their account also. Okay, so suppose this is an account, and this account's name is A, suppose. Clear? And the balance in the account is 1000 rupees, and there is person 1 and there is person 2. They both are joint account holders, and they both have their ATM cards also. Suppose P1 is in need of some cash, okay, and he has an ATM card also. Now he wants to dispense 200 rupees from his account. Similarly, P2 is also in the need of the cash. He wants to dispense rupees 100 from his account. Clear? So P1 goes to the ATM and he inserts his card and asks for 200 rupees. So what will happen at the back end there? First of all, it will perform read A operation. That is, the value of the account will be read first. Clear? And then what will happen? A is equal to A minus 200. That is, because he wants 200 rupees, therefore 200 rupees will be debited from the account. Okay, so this value, this A minus 200, is done at the local site, not at this site. Fine. And finally, it will write A. Write A means the value of A that has been updated here will be written back to the account value. Clear? So what will happen here? First of all, the value of account will be read as 1000. Clear? And then A minus 200 means it is now 800, and finally write A. So 800 will be written. Clear? Fine. So again, now P2 wants to dispense some cash. So at his end, what will happen? It will be read A. Again, A is equal to A minus 100 and write A. So what will happen? Now the new value of A is 800 right now. So read A. So it will read 800 here, and it will be 700. It will be 700, and this 700 will now be written here. So now the new value is 700. Okay, so this 700 is absolutely correct value. Now this is the correct value only if we are performing the operation in a serial way. That is, we are doing P1 first and then we are executing P2, or if we execute P2 first then P1 second, then also the value will be 700. Fine. But we know that in process, context switches can occur. Context switch means, like we studied about the round robin scheduling algorithm, in that one we were switching the context of the CPU from one process to another. That is, we are executing some part of the process and then switching to another process, executing some part of that process, switching to another process, again coming back to the first process, and so on. So likewise, the process can be switched in between. That is, after executing a certain instructions, it can be switched to a different process. Now suppose these two persons, they at the very same time, they are in need of some cash. Fine. And they are unaware of each other's activities. They both know that the value in their account is 1000, but there is a coincidence that they are at the very same time they want to dispense the cash. Clear? So they both went to the ATM. person 1 and person 2, and they both started doing the transaction at the very same time. No difference at all. It is a coincidence. It can happen. Clear? So what will happen? The operating system will switch from one process to another. That is, it will execute one part of process P1 and then switch to another part, again coming back to P1, again going to P2, again coming to P1, again going to P2, and so on. So since these processes need to be executed simultaneously, therefore context switches will happen. So now let's see what happens in this case. Suppose we have this P1. So P1 comes first and P1 executes read A. So what the value of A is read here? It will be 1000. Clear? Now after executing this instruction, CPU switches and it goes to the P2 process. Now P1's state is saved in its PCB, and now we are on to the P2. At P2 it will again read 1000. So 1000 is read here also. Clear? Now again it switches and it comes to P1. Clear? At P1 it does A is equal to A minus 200. So what is the new value? It is now 800. Again it switches and went to P2, and here it will do A is equal to A minus 100, that is it will get 900 here. Again it switches and come back to P1. P1 it does write A. So what is the value? New value will be 800. Again it switches, goes to the P2, and it is writing 900. So the new value, the updated value is 900. However, the cache that we dispensed is 200 plus 100 is 300. So the correct value should be 700. But in this case, the value is 900. So we are in loss of 200 rupees. Clear? Now this situation, although this situation does not happen at all, why does not happen? Because these processes are synchronized with each other. If they are not synchronized, situations like this can occur. However, this situation does not occur at all in our systems. Why? Because these processes are synchronized with each other. Clear? So that is the need why the process needs to be synchronized with each other. That is the main concern. Thank you so much.